Hello, my name is Anton Konushin. I'm a PhD and a team leader of Spatial AI team. I will present the paper Cadrille. Cadrille is our new advancement for reverse engineering of mechanical CAD objects. What's the key idea? In engineering, there is one of the big problems. Sometimes some mechanical part is broken and you need to manufacture another version of this part. But there's probably no technical documentation for this part, so first you need to generate this kind of documentation. So what engineers do? They create a photos of the broken part or scan it with a 3D scanner and have a mesh and a series of photos of this mechanical part. From this mechanical part, we need to produce technical documentation. First, engineers create manually in CAD software this detail step by step using the special CAD software. Our goal is to automate this process as fully as it possible. We use the approach based on multimodal large language model, which is pioneered by the previous paper CAD Recode. The idea is quite simple. We take a scan of the model, sample a number of points from the scan, input it in a modified large language model. Basically, we use some fine-tuned version of the Qwen model. And then it produces a code. In order to produce a code that can generate a 3D model, we use a special library, which is called CAD Query. CAD Query is an API based on OpenSCAD. OpenSCAD is a sort of open source geometric kernel, probably one of the very few open geometric kernels for CAD systems. So, what is the key idea of our Cadrille system if the whole idea of using multimodal LLMs has already been pioneered by CAD Recode paper? The Cadrille has a couple of advancements. The first advancement, that Cadrille is truly multimodal system. It can input either scan of the object, or images of the objects, or text-based description of the CAD detail. These three types of information is supplied to LLM, and it output a code of the model in forms of CAD query. We show that by using these three modes of operation, the system improves dramatically and produces much better results. And the second big advancement is the application of reinforcement learning. Reinforcement learning is a modern technique which is some kind of like Bluetooth. Everything becomes better with the Bluetooth, and everything can become better if you use reinforcement learning. So we divide the process of fine-tuning the LLM into two steps. The first step is fine-tuning LLM on three types of input data. And the second step is fine-tuning with reinforcement learning for specific test data sets. And as our validation experiments demonstrate, this further improves the quality of the results. And one key feature is that for using reinforcement learning, we do not need the exact CAD query code for the detail. We only need a geometric shape. So if you don't have the true answer, the reinforcement learning helps us improve the results on this kind of models also. The Cadrille is a wonderful paper and attract a lot of attention and follow-up works, and we are working on improvement this model even further. So if you're interested in CAD reverse engineering topics, please check our next paper, which is called CAD Reasoner, which we will present at CVPR.